are going to discuss about differential equations of first order and first degree. In that we are going to discuss exact and non-exact differential equations. So starting with exact differential equation, let us know what is a differential equation, what is an ordinary differential equation, what is a partial differential equation, right? So what do you mean by a differential equation? An equation which consists of derivatives, dy by dx, d square y by dx square, these all are called derivatives. So if an equation is consisting of derivatives, that is called a differential equation. So when do we say a differential equation is said to be ordinary? If in the equation the derivatives are ordinary derivatives. Ordinary derivatives in sense the equation should be with respect to one independent variable. Now what is the difference between a dependent variable and an independent variable? See here y and x. X is called the independent variable and y is the dependent variable. How do you remember this? If you take a pillar and you have a base, so basically the pillar is dependent on the base. So here y is the pillar and x is the base. So x is an independent variable and y is dependent variable. So if an equation is with respect to only one independent variable, then it is called a ordinary differential equation. If it is more than one independent variable, assume I have a equation like this. So this is called a partial differential equation, because here the independent variable is not with respect to one variable, it is with respect to more than one variable. So hope you have understood the difference between a partial differential equation and a ordinary differential equation. Next we have to discuss about order and degree. So here order and degree are very mandatory to understand the equation. So first we start with what is order and then we will write what is degree. See, order means highest order derivative, HOD, very simple to remember. And this is degree is nothing but power of HOD. I think this terms you can remember easily. Here HOD in sense highest order derivative. Okay. Now what do you mean by highest order derivative? The derivative which is having the highest order in simple terms. See here in the first equation you are having dy by dx, dy by dx. So here dy by dx is of order 1. Okay. So dy by dx is of order 1. Now what do you mean by degree? Power of highest order derivative. Now both are having same order here. How will you decide the degree? With the highest order. With the highest degree, I'm sorry. So highest degree here is 3. So that is why the degree is 3 and the order is 1. Here coincidentally the order for both the derivatives is 1. Assume you see the second example. In second example, here the order is 1 and here the order is 2. Now we have to take the highest order derivative. For what? To get the order of the given differential equation. So this is the highest order derivative. And how much is the order here? So we are having order 2. And what is the degree? Degree in sense power of the highest order derivative. So the power of this is how much? 1. So that is why here degree is 1 and the order of the given differential equation is 2. Right? Proceeding further. Now we are eligible to discuss what is a exact differential equation. So for an exact differential equation, the equation should be of this form: m of xy dx plus n of xy dy equal to 0. It can actually be even written as m dx plus n dy equal to 0. Okay, where m and n are real values for some x and y. See, sometimes for f of x we even represent it for f also, right? Here also even you can represent m of xy like this as well. There is no issue in that. Okay, so this equation is said to be exact if it satisfies the condition dou m by dou y is equal to dou n by dou x. One thing here you should remember is that this is partial differentiation. This is not normal differentiation. In normal differentiation and in partial differentiation, the difference is that in partial differentiation, you can only differentiate with this respective variable given. That is with respect to only the independent variable. You cannot care about the other variables. For example, 2xy, if I partially differentiate with respect to y, the answer should be 2x. Why? Because here x is constant. So only that independent variable we are differentiating with respect to that. Other variables do not have any significance in partial differentiation, right? Now its solution can be obtained by integral of m dx plus integral of n dy. The down there is some content given here. So this is what in integral of m dx, here y is constant. In integral of n dy, only those terms of n can be considered which are independent of x. Let me explain it in brief. First you write the equation in terms of like this. This is more easy. Okay, here you write terms of n which are independent of y. And here terms of n which are independent of x. You can even write here y is constant. Okay, you cannot write independent of y. This is not possible. Basically, while writing here independent of x, we even write it here. No, we should not write like that. Instead, you have to write y is constant here, and here you should take terms which are independent of x, which is equal to constant. This method can be this method can be understood more by doing a problem. Taking the first problem, you are having dy by dx plus y cos x plus sin y plus y by sin x plus x cos y plus x equal to 0. Okay, so taking the procedure, the equation should be of the form m dx plus n dy equal to 0, and we have to find m and n values as per the procedure. So taking the equation, I think you can cross multiply it. If you cross multiply, what you are getting? Dy into sin x plus x cos y plus x plus dx into y cos x plus sin y plus y equal to 0. Right? So our equation should be of the form what? M dx plus n dy equal to 0. So write the term here. So this is my m, because m dx is coming here, no? This is my m and this is my n. So m is how much? Let me write it here. M is y cos x plus sin y plus y, and n is how much? Sin x plus x cos y plus x. So what is the condition to verify here is dou m by dou y is equal to dou n by dou x. So dou m by dou y, that is partially differentiating m with respect to y, which means other variables are constant here. That is x will be constant. So you take m and differentiate it with respect to y. What you are getting? See, y cos x. So differentiating y cos x, you take the whole and write like this. Now first differentiation with respect to y cos x. Cos x is constant. Dou y by dou y is 1 plus differentiation of sin y is how much? Cos y plus differentiation of y is 1. Now similarly we perform dou n by dou x. That is dou by dou x of, what is my n value here? Sin x plus x cos y plus x. Now differentiating, partially differentiating with respect to x, which means here y has no value, that is it should be a constant. So differentiation of sin x is cos x. Next, cos y is the same, it cannot be changed, so it is a constant, and dou x by dou x is 1 and differentiation of x is 1. So you are getting dou m by dou y is equal to dou n by dou x, which means it has satisfied the exactness condition. This even you can mention as this way, exactness condition. Okay, so if a differential equation is satisfying the exactness condition, then you can say that particular differential equation is exact. Now once we have checked the exactness, now we have to find the solution. So how will you find the solution? Solution is given by what? Integral of m dx plus integral of n dy equal to c, provided here in m y should be constant and here in n only those terms of x, that is only those terms of n which are independent of x should be taken. So in m, y is constant. Where is my m? Here. So in y cos x plus sin y, let me write it here, y cos x plus sin y plus y into dx plus integral of n is what? Sin x plus x cos y plus x into dy is equal to c. So here what is the condition in m? Y is constant. So let y, you write y outside. Now what is integration of cos x? That is sin x. And what did I say? That y is constant. So throw sin y plus y outside. Now integration of dx is x. For n, what is the condition? Only those terms of n which are independent of x. This is having x, this is having x, this is having x. So plus 0. So resulting what you are getting? Y sin x plus x sin y plus xy equal to 0. Implies you can write it as sin, what you can take common? Anything we can take common? We can take y common, I think. So if you take y common, sin x plus x sin y equal to 0. So what solution you are getting finally? You are getting y sin x plus sin y plus y into x equal to c. It's not 0, it's c. So this is the final solution you are getting. So therefore the given question is forming an exact differential equation and it is satisfying the exactness condition, and also you are getting the solution. Let's proceed with the next problem. If you see here for the second problem, x e power xy plus 2y into dy by dx plus y into e power xy equal to 0. Always remember that whenever you are having like this, you just need to cross multiply. So what I will get? X e power xy plus 2y into dy plus dx into y e power xy equal to 0. So equation is of the form m dx plus n dy equal to 0 again. So what is my m value? Y e power xy, and my n value is x e power xy plus 2y, right? Again what we have to do? We have to check the exactness condition. So partial differentiation of m with respect to y. So y here should be, you should differentiate with respect to y and x is constant, right? So y into e power xy. This is UV rule we are applying, okay? So y into e power xy. Again xy differentiation, since x is constant, you write x plus e power xy into y differentiation is 1. Next you are having dou n by dou x. Partially differentiating with respect to x. Okay, x into e power xy into differentiation with respect to x. So you are having y plus e power xy into 1, right? Because differentiation of x with respect to x is 1. And 2y differentiation with respect to x is 0 because you can only differentiate with respect to x. Other variables it will become 0. So what is the answer you are getting? X e power xy plus e power xy. In both the terms, if you see, we can write it like this way also. You just take e power xy common, 1 plus xy. So again, the exactness condition is being satisfied. So this is an exact differential equation. Now we have to find the solution again. The solution is given by integral of m dx plus integral of n dy equal to c. In m, y is constant, and in n, only those terms of n which are independent of x. So where is my m? M. What did I say here? Y is constant. So we will throw y outside. Next, integral of n. N is what, ma? X e power xy plus 2y equal to c. So putting y out, y into e power xy by y. Y is constant, ma, here. Next, what did I say? Differentiation. I'm sorry. Here you have to take only terms which are independent of x. This is having x, you can't take this term. This is having y, we can differentiate, we can integrate. So y square by 2. 2 cancel, y cancel. So what is the solution you are getting? E power xy plus y square is equal to c. So this is the solution. Yes. See, here y is constant. That is the reason why e power xy integration into dx is nothing but e power xy by y. Okay. We will see another problem. I think this we have done. Okay, we are having, okay, let's do with this problem. 1 plus e power x by y into dx plus e power x by y into 1 minus x by y dy equal to 0. These all are various types of problems. Okay, every problem is of different model. So here my m is what, ma? 1 plus e power x by y. What is my n here? E power x by y minus e power x by y x by y. Again here what we will do? We have to perform dou m by dou y. We have to perform dou n by dou x. Verify whether these both are equal. Check the exactness condition. And then you have to find the solution. That is, in m, y is constant. In n, only those terms of n which are independent of x. So dou m by dou y. If you perform the partial differentiation, you are getting e power x by y. Here y is constant. So differentiation of e power x is e power x by y. Next, here this one, I'm sorry. Right. Next, dou n by dou x. E power x by y into 1 minus x by y. Right. So first check the exactness condition, then perform this solution. Okay, you can have a try at this. And this is the fourth problem. We will do, I think, third problem you can have a trial for its solution, and then you can even try fourth one. In next class we are going to discuss problem 3 and problem 4. Just have a trial. And before leaving, I would want to discuss few basic formulas which would be helpful in solving these problems. See, first, integration of x power n is x power n plus 1 by n plus 1. Okay. Next, integration of 1 by x into dx is log x. Everything will have constant. Okay. When we are doing integration, we will have constant. That is mandatory, right? Next, integration of Sin x is minus cos x. Okay, next integration of cos x is sin x. Next you are having integration of secant square x is tan x. Next you are having integration of f dash of x by f of x is log f of x. These all are fundamental formulas which we already read in our previous classes. So these are some formulas which you should remember. I think you have even one more formula. This is also a main formula which is helpful in solving the problems. Integral of 1 by x square plus a square into dx is equal to 1 by a tan inverse x by a. So these are the basic formulas which will be helpful in solving the problems as well as in further class. So thank you.